Okay, so today you guys are going to do a lab using a model seismograph to test earthquake vibrations and the differences between the three following variables. You're going to look at the direction, you're going to look at the distance, and you're going to look at the force. And you're going to see how each of those variables affect what the readings on the seismogram look like. So, how does the location of the earthquake and its waves affect the recordings on a seismograph? That is your overall question. You will have individual testable questions for each variable. So you're kind of doing like 3 mini labs in one larger lab today. So here are your 3 individual testable questions. I went ahead and gave those to you so that we didn't have to spend time doing that. That way you can actually do the lab. So when you set it up, you're going to have a model seismogram, and you're going to have a permanent marker, a tub, and a binder clip. The binder clip will already be attached to the seismograph. All you're going to do is you're going to take the lid off your marker, you're going to put it upside down in through the binder clip and kind of hook the lid on the edge of the binder clip, the lid of the marker, and that way it's kind of suspended so that when you are actually doing the lab, the marker is able to mark on your paper. You will be using the tub as your surface for actually collecting the data. So as I go through this, it'll kind of make a little bit more sense, but you're going to hit the side of the tub in different spots depending on which variable you're testing at the time. Normally in the lab, they have you use a table. Well, our tables are bolted to the floor, so it wouldn't do anything. So we use this tub. You do have to be careful to not knock the tub off the table, but other than that, it works really well. Okay, so as far as question 1 goes, you just need to tell me kind of what you're seeing after you pull the paper slowly through the frame. You're creating your control to where you have something to compare all your variables to at the very end. Make sure to not tear your paper off until the very, very end of the lab. If you do that, then you're going to end up with lots of little sections, and it's not going to make a whole lot of sense. So tear it off at the very, very end of the lab, but this first section you should have needs to say control, no vibrations. So all you're doing is just pulling the paper through the frame to create a line on your paper. Okay, so the first variable you're going to test is direction. So for direction, the first thing you're going to do is pound on the front of, it says the table, but you're actually going to pound on the front of the tub, parallel to the seismograph's arm. So this is the seismograph's arm. You're going to pound on the very front of it, just right below on the tub. And you're going to let it go for, I would say, about 5 to 10 seconds. As one person is hitting it, another person in your group needs to be pulling the paper. Once you have a pretty good reading on there, beside where your reading is on your paper, you're going to write the word parallel. And that way you know that you were hitting, at that point in the data, you were hitting parallel to the seismograph's arm, testing direction. The next thing you're going to do is you're going to hit the side of the tub. So pretend that this table is your tub. You're going to hit the side of it, near where your marker is. And same thing, 5 to 10 seconds. One person's hitting the tub, the other person's pulling the paper. Once you have a good enough section of data, you're going to write perpendicular on the paper. And then the last one is you pounding on the surface. So the easiest way to do this one is to scoot your seismograph to one end of your tub, kind of how this is at one end of the table, and have the person hit on the opposite end of the tub, still on this in a line with where the marker is at. But that'll be the best way to get some results. Same thing, pound 5 to 10 seconds, have one person hit, one person pull, and then you're going to write surface on the paper for that section. Make sure that you use the same person for each of these 3 trials, the same person to hit as well as the same person to pull, because that will help keep extra variables out of it. In addition, you need to make sure that you're hitting with the same amount of force each time. Once again, to make sure that you're only testing one variable at a time. Okay, so the next one we're going to talk about is distance. So you're going to test how the distance affects how the seismograph is reading. So you can use a different person than you did for direction. However, you need to make sure you use the same person to pull and the same person for hitting for all of the distance variable. So the first thing you're going to do is pound close to the seismograph. So this will be, once again, sitting on the table. You're going to pound on the side of the tub that is perpendicular. So your hand needs to be over here on this side of the tub. 5 to 10 seconds while your partner pulls the paper. You're going to label it close to the seismograph, about 10 centimeters away. Then the next thing you're going to do, and I took a picture for this just so that it might help you, you're going to turn your tub sideways, and you're going to move the seismograph to one end. So this is at the very, very end of the tub. And you're going to measure the distance from where your hand will be hitting to where the seismograph is. So your hand should be down at this end of the tub. You need to measure the distance from this end of your tub all the way until where the marker is with a centimeter measuring tape. Once again, you're going to pound for 5 to 10 seconds. Make sure to keep the direction, so you're keeping your hand in the same spot as well as the force constant. When you have your data, label it far away from the seismograph, and then where it says distance on here, I want you to write your distance from your hand that you measured from your hand to the marker. Okay, and the last variable you're going to measure is force. So remember, for this one, you have to keep the distance and the direction both constant. The only thing we're changing is how hard you're hitting the tub itself. So for the first step, I don't want you to pound it all. You're going to create another control. So keep the tub still and just pull the paper strip to where you have a mark on the paper. When you have a decent, couple inch long mark, right? Control, no force. So that means you're not hitting it at all. Then you need to make sure your tub is set up similar to this. You're going to very gently pound on the side of the tub close to and perpendicular to the seismograph's arm. So here's the seismograph's arm again. Here's my hand. This is at the very, very edge of the tub. Pull the paper through as you pound gently. And you're going to mark that section small force, which means that you hit it just a little bit. And then the last one that you're going to do, you're going to leave the seismograph in the same place. You're going to leave your hand in the same place, but you're going to hit it quite a bit harder. Now, don't hit it hard enough to where it falls off the table and breaks. You just want it harder than you had it the first time. Once you have a decent amount of data, you're going to stop and label your strip large force. Then there are 2 sets of questions you need to answer. These are your reflection questions, and these are kind of taking it a step further and applying it to actual seismographs in the real world. Okay? Please let me know if you have any questions. Hopefully this helps. After a group has done the lab, I will post a video of what the lab actually looked like, so for those of you that were gone, you kind of have an idea.